Number 9 is -4. 12 is 8. 15 is 1. 18 is 2. Then we go to 21. 21 is 4. Then we go to 33. You rewrite it as 3 log base 2 of z. 36 you rewrite as 1 minus ln x. 39 you rewrite as 2 log base a of u plus 3 log base a of v. 42 is ln x plus a half ln of 1 plus x squared. 45 you rewrite as log x plus 2 minus 2 log of x plus 3. 48 you rewrite as 4/3 ln x minus 4 minus 2/3 ln x squared minus 1. Or you could split that x squared minus 1 to x plus 1 and x minus 1. 54 is log base 2 of 1 over x cubed. 57 is ln of x plus 1 over x minus 1 all over x squared minus 1. Or you could simplify it to ln of 1 over x minus 2 quantity squared. 60 is log base 3 of the cube root of x to the 21st times 9x squared divided by 9. You could simplify it and it becomes log base 3 of x to the 9th. 63 simplifies to log base 2 of x plus 1 squared over x plus 3 and x minus 1. 66 is 1.796. 69 is 5.615. And 72 is 0.303. Please come with questions over those for next time. Today we're going to learn one property, and it states that if you have a single logarithm on each side and they have the same base, that what you're taking the logarithm of will equal one another. It's kind of like our exponent property. So if we look at this problem, we have log base 4 of x plus 2 equals log base 4 of 8. So since we have a single log on this side and a single log on that side, your logs pretty much go away and you just say x plus 2 equals 8. They both had the same base, so that's why you could do that. So if you solve for x, you get 6. You must check your answer, so plug 6 back in and see if it works, if each side equals one another. So here, yes, we have a single logarithm on each side, but there's an issue. What is that issue? You should say that this has a -2 in front. It cannot. So if we rewrite and put it as an exponent, then you can solve this problem. So I would get x to the -2 equals 9. Well, how do we solve x to the -2? Can you do the -1 square? No. So what we're going to do is we're going to write this as 1 over x squared equals 9. Crisscross, and you get 1 equals 9x squared. Divide by 9, and you get 1/9. Now unsquare, and you get x equals 1/3, and you would get x equals -1/3. However, when you plug in -1/3, it will not work because this quantity right here cannot be negative. Your subscript can, but this number never will be. So this answer is invalid, and you just get x equals 1/3. So here we got 3 log base 2 of x minus 1 plus log base 2 of 4 equals 5. You do not have a single logarithm on each side. This side has 2, so let's combine that side and make it a little bit easier. So combine it, unpause the video, and then see if you got it correct. So you combine this, you would get base 2 of x minus 1 to the 3rd, because at 3, you would get times 4. The reason you would get times 4 is because it says plus. So you don't have a single logarithm on each side, but you have solved problems like this before, and you have rewrote it in exponential form. So if there's not a single logarithm on both sides, if you just have one logarithm on one side, you have to go to exponential form. So to go to exponential form, our exponent is our base, or our base is our subscript, our exponent is what we equal, And all this other jazz is what goes on the other side. I'm going to go ahead and move the 4 in front. So I would take 2 to the 5th and get 32. Some of you are like, ooh, let's distribute the 4. You can't distribute the 4. Some of you are like, ooh, let's cube that. Fine, cube it. You got to do 2 area models. But I would divide by 4 and get 8. Then I would uncube and get 2. Then I would add 1 and get 3. So if you plug 3 in here, we got 3 minus 1, that's 2. That's positive, so it's okay. So see if you can do this problem on your own, considering what we did last time. You should rewrite and get x times x minus 3 equals 1. So you rewrote it as a single logarithm. Now, since there's not a single log on both sides, you need to rewrite it in exponential form, excuse me. I would figure out what 4 to the first is, that's 4. On this one, since x is in 2 spots, I would distribute and get x squared minus 3x. Anytime you have x squared, what do you have to do? You should say quadratic formula, so set it equal to 0. And you can do quadratic formula, or you can factor. I can see the factors of this right away. So I get x minus 4 and x plus 1, because negative 4 and positive 1 multiplied equal negative 4. Negative 4 plus 1 equals negative 3. So I did that. So this factor gives you x equals 4. This factor gives you x equals negative 1. Let's test them. If I plug 4 in here, it's okay. If I plug 4 in here, it's 1, so it's okay. If I plug negative 1 in here, negative 1. Plug negative 1 in here, negative 4. Can't do a negative, so it's bad. So 4 works.